Okay, so last class we talked about multiplying and dividing exponents. So numbers 1 through 5 is kind of a review. So if you want, you can pause now and try them out on your own. If you would like to follow along, that's okay too. So for number 1, you have 4 to the second power times 4 to the seventh power times 4 divided by 4 to the third power times 4 times 4 to the fourth power. The first thing you need to do is combine everything in the numerator and everything in the denominator. So we're going to start with the numerator. Remember that when it does not have an exponent, there's an understood 1. So it's 4 to the second power times 4 to the seventh power times 4 to the first power. Your base is 4, so it stays 4. And 2 plus 7 plus 1 is 10. Looking at the denominator, 4 to the third power, remember that second one is the same thing as 4 to the first power, times 4 to the fourth power. So 3 plus 1 plus 4 is 8. So now I have 4 to the eighth power in the denominator. The next thing you need to look at is where is the exponent larger? Is it larger in the numerator on the top or larger in the denominator on the bottom? For this one, it's larger on the top. 10 is larger than 8, so it stays on the top. And 10 minus 8 is 2. So 4 to the second power is the correct answer. Okay, so fractions. 1/4 to the third power times 1/4 to the first power times 1/4 to the second power. You're going to do the same thing as you did before. Combine everything on top. So it's 1/4, and 3 plus 1 plus 2 is 6, divided by 1, 2, 3 of those together make 1/4 to the third power. Again, it is larger on the top, so it stays on the top. I'm going to write it up above here, and it becomes 1/4 to the third power. Finally, number 3, you have constants. Remember, constants are those numbers that are not exponents that are next to the variables. Variables are the letters. So we're going to deal with the constants first. So 3 times 5 times 6. Well, 5 times 6 is 30. 30 times 3 is 90. So 90 is the constant in the numerator. Then we're going to look at the denominator. 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is 30. So we have 90 over 30. Both of them have x's and y's. So we're going to write x's and y's. And now we need to add up all that they have. So in the numerator, x to the fourth and x to the sixth becomes x to the 10th. And then you just have y to the third. In the denominator, I have x to the second. That's my only x. And then y to the 1 and y to the third becomes y to the fourth. Now we need to combine everything that we can. So we look at our constants, and 90 divided by 30 is 3. It is larger in the top, so stays in the numerator. Now x is larger in the numerator also. X to the 10th over x to the second becomes x to the 8th. But now we look at the y's. Y is actually larger in the denominator. Y to the fourth is in the denominator, and y to the third is in the numerator. So y, or y to the first, stays in the denominator, and there's your final answer. Number 4, 6 to the seventh times 6 to the third times 6 to the second. In the numerator, that becomes 6 to the 12th. In the denominator, I have 6 to the first times 6 to the fourth times 6 to the fifth, which becomes 6 to the 10th. It is larger in the numerator, so it stays in the numerator, and 12 minus 10 is 2. Number 5, again, we look at constants first. I have 4 times 9 in the numerator, so that becomes 36. And I have 2 times 6 in the denominator, which becomes 12. Then we look at the variables. In the numerator, I have a to the fourth and a to the third, which becomes a to the seventh. And b to the fifth is the only b in the numerator. In the denominator, a to the second times a to the second becomes a to the fourth, and b to the second is our only b in the denominator. I'm going to move the answer down here. So first, the constants. 36 divided by 12 is 3, which stays in the numerator because 36 is larger. Then a to the 7 over a to the 4, it's larger in the numerator, becomes a to the third. And b to the 5th over b to the 2nd becomes b to the 3rd. And there's your final answer. All right, if you didn't notice, the notes for this one is called power of a power. Number 6 and number 7 are examples of questions that have power of a power. So for number 6, it says 2 to the 4th power raised to the 3rd power. What does that mean? If you're not sure, let me just spell it out for you. It's 2 to the 4th power times 2 to the 4th power times 2 to the 4th power. Okay, from the knowledge that we had before, when I multiply a number that has the same base, that base stays the same. Then you add the exponents. So 4 plus 4 is 8, plus another 4 is 12. So 2 to the 12th power is your answer. Then we look at the next one, which is what does n to the 2nd power raised to the 5th power mean? Well, that means n to the 2nd power times itself 5 times. So again, n, and then I have 2, 4, 6, 8, 10 for your exponent. So n to the 10th power is your answer. So hopefully you've noticed that on the first one, 2 to the 4th power raised to the 3rd power, that answer became 2 to the 12th power. And n to the 2nd power raised to the 5th power became n to the 10th power. What is happening between the 4 and the 3 to become 12? And what is happening between the 2 and the 5 to become 10? If you read the rule down below, it says when you raise a power to a power, you keep the base and multiply the exponents. So 4 times 3 is 12, and 2 times 5 is 10. So a to the m power n to the n power is a to the m times n. Number 9, 15 to the 3rd power to the 9th power. Your answer is going to be 15, and then you're just multiplying 3 times 9, which is 27. So 15 to the 27th power is your answer. Next one, the reason why you have so many parentheses there is because remember that is a negative base, so it keeps its parentheses. But again, you just multiply the exponents, and 5 times 8 is 40. And finally, a to the 17th times 4. Some of you want to take out a calculator on that. Please do not. You do 10 times 4 and then 7 times 4. 10 times 4 is 40. 7 times 4 is 28. Add them together and you get 68. So it's a to the 68th power. Okay, so 3 to the 5th over 3 to the 2nd became 3 to the 3rd. Then we look at 3 to the 5th over 3 to the 3rd becomes 3 to the 2nd because 5 minus 3 is 2. Then 3 to the 5th over 3 to the 4th becomes 3 to the 1st. And then I have 3 to the 5th over 3 to the 5th, which becomes 3 to the 0 power. So the expression that we wrote was 3 to the 0 power. The exponent we used was 0. But then it says down below on number 2, using factored form, find the value of 3 to the 5th times 3 to the 5th. Oh, divide by 3 to the 5th. So we do 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3 times 3 times 3. You look at this, these cancel out, these cancel out, these cancel out, these cancel out, and these cancel out. So I end up with 1, or 3 to the 0 power. So based on your findings, what can you conclude about the value of 3 to the 0 power? Just like I listed before, it is 1. Remember, anytime that you have a number that is the same in the numerator as it is the denominator, 4 divided by 4 is always 1. That would also have become 4 to the 0 power because 1 minus 1 is 0. So for number 4, it will always equal 1. If you would like to, you can use a calculator to check your prediction for several numbers and see if you are correct. So the rule for this one, a non-zero number, so that means any number that is not 0, raised to the 0 power is equal to 1. So a to the 0 power is always 1. It's really hard to write on the screen, guys. I hope you understand this. My handwriting is getting terrible, but it's really good in real life. All right, for the next 4 problems, 6 through 9, you can do them on your own by pausing now and then checking, or you can follow along. Number 6, 7 to the 3rd times 7 to the 0 power. You could automatically understand that that is going to be 1, so your answer is 7 to the 3rd power, or you could have looked and saw that 3 plus 0 is 3. All right, number 7. This one's a little bit more difficult, so what you need to do is actually go through, actually just kidding, because that's scientific notation, and we're not going to go there yet. So you'll learn that later. Go ahead and cross it off for now. Yay. Okay, number 8. 4 to the 2nd power times 4 to the 6th power divided by 4 to the 8th power. So 4 to the 2nd times 4 to the 6th becomes 4 to the 8th. And notice how I now have 4 to the 8th on each one. Those will become 0, which will always become 1. All right, number 9 is kind of hard to see what you're doing until you rewrite it. So I have a to the 4th divided by a to the 0, and this is all going to be times a to the 3rd. This is a lot easier than it looks, because remember this becomes 1. So it's really just going to be a to the 4th times a to the 3rd, which is a to the 7th. So this table looks a lot like the one we did on the other page. So you're going to do the same thing you were doing before. 4 to the 5th divided by 4 to the 4th is 4 to the 1st. And the reason why these become whole numbers, they haven't understood 1 in the denominator, because their exponent was larger in the numerator than it is in the denominator. You'll see the next one becomes 4 to the 0, and then we're going to switch a little bit, because 4 to the 5th is actually smaller than 4 to the 6th. So we're going to have a 1 in the numerator and 4 to the 1st power in the denominator. And then the last one, same thing, because 4 to the 7th is actually larger. It is going to be in the denominator, and that's not going to be 7, it's going to be 2, because 7 minus 5 is 2. All right, if you look back at the table, you will see that you wrote 1 over 4 to the 1st power for that one. So using factor form, find the value. We had 4 times 4 times 4 times 4 times 4. That is 5 fours. Over now 6 fours. And if you were wondering why I was laughing, it's because Miss Falk was talking and she was interrupting my video. You'll see that these all cancel out. So we were correct. It became 1 over 4, or 1 over 4 to the 1st power. You would do the same thing for number 12. So it would become 1 over 4 to the 2nd power, because you would have 2 4s left over instead. So a to the negative n power is the same thing as 1 over a to the n power. How would you write a to the negative 3 using a positive exponent? If you looked at what you just wrote on the rules, you would have seen that the rules, we had a to the negative n is the same thing as 1 over a to the n. So using that, you would see that a to the negative 3 is going to be the same thing as 1 over a to the 3rd. See, it says positive exponent. That's a positive exponent. So write your answer using a positive exponent for 14 through 17. Pause now, try them on your own, come back and check your work. What I'm going to do first is I'm going to combine, because 13 to the negative 4 and 13 to the 7, that's going to be the same thing as 7 minus 4, which is 3. Then we look at number 15. In order to make this negative 7 positive, we have to move it to the opposite side. So now we have 1 over, because it's no longer in the numerator, and in the denominator we can combine the 4 and the 7 to make 11. That is your final answer. 16, if I combine them, I get 4 to the negative 2, which is not correct. If you look up above, you would have remembered that to make that positive, it would be 1 over 4 to the second power. And then for 17, if I have x to the negative 7 and x to the negative 4, we could do this kind of like how we did number 15, or we can make both of them positive before we answer it. So to make them positive, you have to move them to the opposite. So if it's in the denominator, it's now positive in the numerator. If it's negative in the numerator, it's now positive in the denominator. For this one, x is larger in the bottom, so it becomes 1 over x to the third power. All right, for the last 4, again, try them on your own and then check your work to see if you did it correctly. When you have a negative 1 as the overall power, it's the power of a power, what that means is if it's a fraction inside that parentheses, you're going to flip the numerator and denominator. So this is going to become 32 n to the 0 in the numerator and 8n to the 5th in the denominator. You may have noticed that n to the 0 power will become 1, so it's actually gone. Then we have our constants, 32 divided by 8, which is 4, and we still have an n to the 5th left over in the denominator. There's your final answer. For number 19, 14a to the negative 5 divided by 7a times 2a to the negative 4. So what we're going to do is we are going to not move the background. We are going to rewrite this as 14a to the negative 5 over 7a times 2a to the negative 4. You always want to simplify things as far as you can before you start actually working with the numbers. So we're going to look at 7 times 2 in the denominator becomes 14. And then I have a to the 1 times a to the negative 4, which becomes a to the negative 3 if you were to combine them. And then I have 14a to the negative 5. By doing that, you will see that these 14s will actually cancel each other out. You won't have to deal with those at all because 14 divided by 14 is 1. And now we just have our a's to deal with. The a to the negative 3 becomes positive by moving it into the numerator. The a to the negative 5 becomes positive by moving it into the denominator. And you will see that it is larger in the denominator. So 1 over a to the second becomes your answer. And number 20 and 21 say simplify each expression and evaluate where applicable. So this becomes 1 over negative 6 to the first power, or 1 over negative 6. The second one becomes 3 to the negative 4, because negative 5 and 1 makes negative 4, over 5 to the negative 3. To make these positive, we switch them, so it becomes 5 to the third, over 3 to the fourth, and then it used this word, evaluate. Evaluate means actually go through and multiply. This might be a little bit more difficult to do without a calculator, but 5 times 5 is 25, times 5 again is 125. Then I have 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. And that is all you can do with those ones, because 125 is just 5 and 3, 5, 6, 7, 8, just 1 and 5. So that is all you can do. So there's your final answer. And guys, you just did it. You finished. So make sure you finished all of your notes. If you missed something, go back and fill it out. If you have questions, ask Ms. Falk or Mrs. McLean, and we can hopefully help you figure it out. Good luck, and we'll see you next class.